So first, thank you all for attending this presentation. I'm Axel Richard, consultant at OBEO. Today, I will show you how we have migrated an existing Eclipse RCP application named NabLab to a VSCode extension. In this talk, you will see the challenges of creating a VSCode extension to manipulate the NabLab DSL, the existing one from Eclipse, not a new one, by using technologies such as LSP, Xtext LSP, and Sirius Web. In other words, how we succeeded in getting the image on the right of the screen from the image on the left. We will try to focus on the challenges faced during the development, how to share the same Xtext grammar between an RCP application, an RCP product and a VSCode extension, how to share the same Xtext grammar editor tooling between an RCP product and a VSCode extension, how to reuse the Sirius desktop model specification file with Sirius Web. As you can see, one of the main goals was to keep the existing versions of grammar, tooling, and configuration files as much as possible. Okay, so the first part will be a presentation of NabLab, what's its goal, what it looks like, and what are the technologies involved. Then, in a second part, we will see why the CEA wanted to provide NabLab through a VSCode extension instead of an Eclipse RCP product. Finally, we will see what are the technologies involved and how have we done. So, what is NabLab? It is an open source research project led by the CEA, the French Alternative Energies and Atomic Energy Commission. NabLab provides a productive development way for high-performance computing, also known as HPC. HPC is the practice of using parallel data processing to improve computing performance. If you want more information on the subject, please visit the NabLab website. NabLab is essentially a domain-specific language, or DSL, for numeric analysis, helping mathematicians to develop algorithms and generate optimized code, mainly C++, but also Java or Python. NabLab comes with an Eclipse RCP environment, allowing to manipulate this textual DSL through a rich textual editor with all the tooling expected, such as the code completion, the syntax coloring, or the error detection. It also provides an enhanced view for the display of mathematical formulas, a diagram view, and the possibility to generate source code. So let's go for a demo of the NabLab RCP product. Okay, so on the left, I have my model explorer, my project explorer, with all the files I need. So the NabLab file and the NabLab files, which are my two grammars. So if I open a NabLab file, a .n file, I have a NabLab DSL editor with all the tooling expected, such as the code completion. I also have the syntax coloring, here are the commands, but also the variable types, all the keywords of the grammar, but also the numbers. I have the error detection. Here I provided a natural value, but a real value was expected. We also have on the bottom of the screen the mathematic views, also known as the LaTeX view, which display a formula, a mathematic formula, based on what is selected in the NabLab editor. It is updated each time the selection is updated in the NabLab editor. Then I have the NGen NabLab file, which basically contains configuration for the output code, generated code. and some other configuration and parameters. And from this NabLab gen file, you can also generate a diagram. Then from this NabLab gen file, you can also generate source code. And in this case, a Java file has been generated. You can see a trace in the console showing you what has been generated. And then you can see the generated code with the Java editor. So first, let's talk about the DSL editor. The DSL, its editor and the tooling are powered by Xtext, the famous framework. Xtext-related code have been put in two plugins. The fr.ca.nablab plugin contains the grammar and all Xtext-related configuration and customizations. The fr.ca.nabla.ui plugin contains all UI tooling-related code. This UI non-UI separation is often useful and, in our case, was essential. The UI plugin is indeed strongly tied to the Eclipse UI framework and ipso facto not usable in VSCode. Then we have the diagram view. This view is powered by Sirius, the famous framework to create your own graphical modeling workbenches, and developed by OBEO. Here is a screenshot of a Sirius modeling workbench with the Model Explorer view on the left, displaying some models, model elements, and the diagrams associated. Then you have a diagram opened in the main central area with a palette on the right. This palette allows you to easily create diagram elements. On the bottom, the properties view allows to edit the properties of the selected elements. In NabLab, Sirius has been used in a specific way, with no serialization of the graphical model, no display of the graphical representations in the Model Explorer view, a read-only diagram with no creation tool, and no properties view. So basically, only the diagram part. All Sirius-related code and configuration files have been put in fr.ca.nabla.sirius plugin. Here you can see the Sirius configuration file containing the description of all graphical elements in the diagram. Then, on the bottom of the UI, mathematic formulas enhanced view, also known as LaTeX view, synchronized with the NabLab DSL editor. This view only displays an image generated from the selection in the active NabLab editor. Each time the selection is updated in the editor, a new image is computed and displayed in the formulas view. So, why the CEA wanted to migrate to VSCode? VSCode is widely used by NabLab mathematicians because of the C++ extension. NabLab users were switching between the NabLab Eclipse RCP product by modeling and then generating code, and then return to VSCode to test and debug this generated code. From now on, they will be able to do that in the same environment, which will improve their productivity. So our first challenge was to reuse our Xtext grammar. We didn't want to duplicate it or use another technology. Fortunately, LSP and Xtext LSP module were there to solve our problematic. According to Microsoft, a language server is meant to provide the language-specific smarts and communicate with development tools over a protocol that enables inter-process communication. On the screen, you can see an image coming from the Microsoft LSP website, showing a no LSP architecture on the left and the LSP architecture on the right. With LSP, you should be able to write your language server once and reuse it in multiple development tools. Okay, so that seems to do the job. So we should be able to implement a language server for NabLab. But is Xtext providing the support of the language server protocol, allowing to implement a language server for NabLab? Yes, it does, with Xtext LSP. If you need more information on the LSP support in Xtext, please visit its website. So the minimum required on server side is to have your own Xtext server launcher. By the way, on the server side, all the code has been written in Xtend. On client side, that is the VSCode extension project, you need to depend on VSCode language server and language client. Then you can add the following configuration in the package.json file of your VSCode extension. Here we contributed a new language and a new grammar called NabLab, as you can see on the screen, and another one for the NabLagen grammar. Here is a screenshot of NabLab running in VSCode. Now, when a NabLab file is opened, the editor recognizes the NabLab grammar. Okay, now we can run our Xtext grammar in VSCode. But how about the editor tooling, such as the content assist, the syntax coloring, etc.? We also wanted to reuse existing tooling if possible. Again, Xtext LSP has helped us to do that. The content assist is provided by default, but you can customize it by implementing your own Xtext IDE content proposal provider. What is important to remember here is that Xtext allows you to customize every aspect of the tooling. Same for the Over service. We use the custom version of the Xtext Over service. The same service is used for both RCP product and VSCode extension. For the syntax coloring, it was not possible to reuse the one provided in our Eclipse RCP implementation. We had to provide a configuration file allowing to specify which symbols are used as command delimiters and other type of delimiters. Then we also had to provide a text-made file for the tokenization. The tokenization of text is about breaking the text into segments and classify each segment with a token type. Here you can see the commands and the keywords tokens. Okay, so now we have a super editor in VS Code with tooling, but how about the diagram view? The Sirius desktop framework used in our RCP product relies on Eclipse UI and Eclipse GMF for its diagram views. We know that Sirius Web exists, but we would like to reuse the same Sirius desktop specification file, the ODesign file, if possible. So, is it possible to do that? Yes, it is possible with the compatibility layer from Sirius Web. Here is a screenshot of NabLab diagram, of a NabLab diagram, powered by Sirius Web and running in VS Code. The diagram is computed from the NabLagen file. The display is not synchronized with the grammar. Users have to launch the computation and display the diagram manually. It is the same behavior done in the RCP product. First, the compatibility layer from Sirius Web is not the recommended approach. Indeed, Sirius configuration file capabilities are not fully handled by the compatibility layer. But our case seemed a favorable case. The NabLab diagram is quite simple, with no creation tool, and in a read-only mode. We also don't reuse the Sirius Desktop Model Explorer or Properties View. If you need more information on Sirius Web, please visit its website. OBEO also have a booth during the whole conference, so feel free to come and visit us. So on the back end, we have created a Spring application using only some components of Sirius Web, such as the diagram component or the compatibility layer component. The component architecture of Sirius Web allows you to use only what you need. These components are stored in a specific library called Sirius components. We also depend on the NabLab Sirius plugin for the NabLab Sirius configuration file. Indeed, we wanted to reuse the configuration file. Thanks to the compatibility layer, we only had to list the Sirius configuration file to consider. Here, the i1.o design file stored in our fr.cea.nabla.sirius plugin. On the front-end side, we also depend on Sirius components, the framework containing the building blocks from which Sirius Web applications are built. We use the VSCode web view to display the diagram view. In this web view, we use the React components provided by Sirius components, especially the diagram WebSocket container React component. Now, about the mathematical formulas enhanced view, the LaTeX view, the goal was, again, to use the same principle than in the RCP product, that is the generation and display of an image based on the selection in the active NabLab editor. When I click anywhere in the active NabLab editor, the formulas view on the bottom of the screen should be updated. So we use the LSP commands mechanism to do that. First, the client calls the command with the appropriate ID, here nablabweb.updateLaTeX. The command is sent to the server, waiting for the response. Then, when the response is sent back, the formulas view is updated with the new image. On the server side, we implemented an Xtext executable command service. When a command is executed on the client side, the server is waiting for it and will try to execute the command. If the command has nablabweb.updateLaTeX as ID, then we generate an image and send it back to the client. It is also possible to generate code from a NabLab file. Here, the goals remain the same. Try to reuse what has been done in the RCP product. On the client side, in the package.json file of our VSCode extension, we declared a command and a context menu in the Explorer view. This menu will only be available when the selected file is a NabLab file. Then we registered the command when the extension is activated in the main class of our extension, extension.ts. We also use the LSP commands mechanism to call the code generation. First, the clients call the command with the appropriate ID, here nablabweb.generateCode. Then the command is sent to the server, but in this case, not waiting for a response. The server will generate code in the appropriate folder. The client doesn't need a return value or to wait for a return value. On the server side, we use the same Xtext executable command service for the generation of the image. When a command is executed on the client side, the server is waiting and will try to execute the command. If the command has nablabweb.generateCode as ID, then we generate the code. Again, we just had to reuse the same method than the one already existing for the RCP product. So let's go for a demo of the NabLab, but this time as a VSCode extension. Okay, so it's basically the same. You have Project Explorer on the left with your NabLab and NabLab gen file and generated code. So if you open the NabLab file, you have the same DSL editor than in the RCP product with the same code completion. It is the same code that is called, so with the same result. You also have the syntax coloring with the commands, the variable types, the keywords. You have the error detection with the hover service showing the same message than in the RCP product because the same code is called. In the bottom of the UI, you have the LaTeX view, which is updated each time the user selects something in the NabLab editor. Then from the NabLab gen file, you can generate your diagram, but this time a Sirius Web diagram. So it's the same. And you can generate the code from your NabLab gen file. So right-click Generate Code, and it generates the same code. In the output, you have the same trace than in your RCP product. And the generated code is also the same one. Okay, so just a few words about the build and the packaging. The NabLab RCP product was built with Maven. So we have adapted the build to include the NabLab LSP server, the NabLab Sirius Web application, and the VSCode extension. At the end, the VSCode extension is pretty big, around 90 megabytes, because it contains all required technologies such as Xtext, Sirius, Spring, and many others along with their dependencies, which represent around 170 jars. The packaging of the VSCode extension has been done with VSCE, command line tool, to produce a VSIX file. VSIX files are the VSCode extension files. The build and packaging are handled by GitHub Actions in the NabLab Git repository. So in conclusion, we can consider the migration to be a success because we share the same Xtext grammar and the same Sirius configuration file in both RCP product and VSCode extension without loss. The migration has been much more complex than presented in this talk, like the fact that we use two different grammars. I also only quickly show the trace output, and I didn't mention all the adaptation I had to make on the existing code to separate the UI, non-UI concerns, and also all the evolution I had to make in Sirius Web and in Sirius Web in order the migration to be a success. So thanks to the CA for supporting OBEO through the years and investing in open source technologies such as Sirius Web. Thanks to all partners investing or using in OBEO's open source technologies. So please visit OBEO booth if you want more details. So thanks for attending this presentation. If you want to try it, you can download NabLab RCP product or VSCode extension from GitHub. If you want to know more about the CA and OBEO, please visit their website. So thanks again for attending, and if you have any question, do not hesitate. Thank you.
So it looks like the original diagram specification used colors for a bright theme. So do you have ideas how that could be adapted to include bright and dark themes? I mean, because I think this is quite often a challenge when diagramming.
Yes, it hasn't been. So the question was for the diagram part, as you can see maybe on this screenshot, you can see that VSCode by default, the default theme is dark mode, and the diagram is still has a white background. So this concern hasn't been addressed in this in my work, but yes, at the end it would be great to have also a dark mode for the diagram part, but we probably also should modify the Sirius desktop configuration file to say, okay, if it's dark mode, so use this color, and if it's bright mode, use this color. But it's probably need some evolutions to do that. So for the moment, it's not in the pipe.
Because Eclipse now has the dark mode as well, so it's basically the same problem there, and I think it's a general channel how to get good colors both for bright and dark in a diagramming context.
Yes.
My question is, thanks for the talk at first. My question is, you were telling about the Xtext language server and the Sirius web server, and my question is, how are they related to each other? Does one include the other, or do they coexist? And how does the front end communicate? So is it via TCP or via standard in, standard O?
Okay.
IO? How does that work?
Okay, so the question was about the Xtext language server and the Sirius web server. So they coexist. The Xtext server do his thing on his side, okay, and from the NabLab gen file we generate a diagram. So when user click on in our case F2 from the NabLab gen file, then a diagram is generated and open. So only at this time it generates a diagram and Sirius Web is involved. So Sirius Web is never involved at other time of the process.
So the Sirius web server doesn't process the DSL content actually, but just this engine. Does the Sirius web server process the DSL content or just this engine content?
Sorry. J'entends pas, je suis désolé. Okay, so it is another grammar. It is an intermediate grammar from the engine file, so the NabLab gen file. It generates another grammar which is called IR models, which are IR models. And from these IR models, we can display a grammar based on these models.
Okay, thank you. Who wants to have the hot potato?
No questions? Okay. So thank you very much.